The 6000 series oscilloscope has two acquisition modes. The default mode is called scope mode, and this provides a triggered YT display. The second acquisition mode is called persistence mode, and this takes again multiple triggers but overlays each display on the screen, and this mode is used for looking for random events on a data acquisition. So this could be any noise, any overshoot, ringing problems, any glitches that are occurring on signals, anything that is random in nature. There's much more likelihood to find this in the persistence mode. In this demonstration, we're going to look at a particular signal that has a repeating clock pulse, but also there's an asynchronous anonymous ringing signal, which we're going to use the persistence mode to analyze and see if there's any correlation between the two signals. So the first thing we could do in the real-time mode is to try and trigger on the ringing burst of pulse. So I'll just lower the trigger level, and we can see it is possible to trigger on it. So it is a repeating burst of pulses, and we could see if there is a duration time that this is occurring on. So we'll just change the time base to a slower time base, and indeed we can see it's repeating at a particular rate. So we could measure this with the cursor. So we could put a cursor on the trigger point and then a cursor on the previous occurrence of the event. So here we can see that this occurs every 3.58 microseconds. So this may give a design of this circuit a clue to the source of this signal. And now I'll just close the cursors. So I'm going to move the trigger point up again and trigger on the main signal and increase the time base sweep rate. So now I'm going to use the persistence mode to have a look at this signal with the overlay display. So here straight away we can see building up the set of bursting pulses, and indeed we can see it does occur randomly everywhere, and indeed even it gets added to the top of the pulse. So it does truly seem to be asynchronous. So the next thing we could try now is to trigger again on the set of ringing pulses. So I'll just bring the trigger level down again, and now yes, we can trigger on it, but we can see some extra thing here, that the main pulses never seem to occur when the bursts of ringing pulses occur. So I'm just going to make the time base faster sweep rate to confirm this, and indeed yes, we can see that this signal, when it's present, the main burst of pulses never occur. So again, there is some correlation between the two signals, which we couldn't see in the real-time mode. So just to show that again, if we put back to real-time mode, it would be very difficult to come to that conclusion in the real-time mode, whereas in the persistence mode we can see that this doesn't actually ever occur at this point when we trigger at that point. So here we are with the triggered event, and again that never occurs at that point. It's possible to optimize the color display in the persistence mode, and this is in the persistence options menu, and here so we now have a digital color, and a second option here is analog, so we can give simulating an analog display, or indeed there's a third choice of advanced, and this gives then more variations on that. So we can actually change the phosphor again to color and give a color display, but now in this advanced mode we can actually change the decay time, so we can change the decay time, how long the signal's on the screen before it decays away. So all these can give a customized display when you're looking for particular events on any chosen signal. And again, you can change the saturation, and this may show additional information about the acquired data.